Okay, these are your notes for section 6.1, quadratic expressions, rectangles, and squares. And we are live here from Mathland with a live studio audience. And shout out to the people who are being very pushy, Connie and Sydney. And Jessica. Okay, here we go. Objective and what's the point? We are going to review area of rectangles and squares. I hope you guys know how to find the area of a rectangle and a square, but we are going to use quadratic expressions, so that might be something you don't remember. We are going to expand products and squares of binomials. Some of you right now are saying, what's a binomial? But that's what we're going to do. And why are we going to do this? Because we are going to study quadratic functions. Okay, recall. Who knows what a monomial is? Yeah, okay. A monomial is one term. There's no plus or minus sign. Some people right now will say, oh, Miss Bruno, you made a mistake. There's a minus sign. Guess what, kids? That's a negative sign. Negative signs are okay. Plus and minus are not. These are all examples of monomials. 2x, 3x squared y, and negative 1/2 x y squared z cubed. This is a pretty complicated monomial. Most of them will look more like these simple ones. But it could go on forever. It could have 24 like variables, but it just has one term, no plus or minus signs. Okay, the degree of a monomial. A degree is obviously going to be a number. You guys remember that because the degrees of temperature is a number. The degree of the monomial will be the sum of all the exponents of all the variables. So going back to our examples up here, 2x, there is an exponent of 1 here, so that is a degree of 1. That monomial has a degree of 1. This one, x squared, y the first, 2 plus 1 is 3. And negative 1/2 x y squared z cubed, there's a 1, plus 2 is 3, plus 3 is 6. So the degree of the monomial is what the sum of those exponents are. Okay, polynomial. I always said if I had a parrot, I would name it polynomial. So they would say polynomial wins a cracker. And I think it would be really funny. But in all seriousness, polynomial, you guys should know this prefix poly from science, I hope. I don't remember. Is there some chemistry like poly something in chemistry? Polygons. That's in geometry. What's the chemistry one? Poly what? Did somebody say it? There is something like poly something chemicals. Like, I don't know. You guys aren't even helpful. Basically, what a polynomial is multiple monomials, and we combine them. The way we combine them is with addition or subtraction. Polyatomic? Yes, that could be it. We use addition or subtraction. This is an example of a polynomial. You've seen these before. These are the types of things that you would type in to your graphic calculator or something to graph. 3x squared plus 2x squared minus 4x minus 8. That is a polynomial. This polynomial consists of 1, 2, 3, 4 monomials. Okay? This is a polynomial as well. X squared y minus x cubed y, and that just has 2 monomials. The degree of the polynomial. This is tricky. You don't add everything. You look at each monomial and you pick the one that's highest. So in this one, this is a degree 3 polynomial because the biggest degree of the monomial is 3. In this monomial has a degree of 3. This monomial has a degree of 4. So we say that it's a 4th degree polynomial because you go with the highest degree there. This may seem really random, this area of a circle thing, the pi r squared, but that's going to show up on a homework assignment. So that's why that's there. Okay, moving right along. Words to know. These might be new, but you should have seen them in algebra. A quadratic is anything with degree 2. So here are some examples of the way that might look. Ax squared plus bx plus c. This is a quadratic expression. It's an expression because there's no equal sign. We just saw that on the last test. Expression is different than equation because equation has to have the equal sign. So it's quadratic equation, ax squared plus bx plus c equals 0. This is actually called standard form when it's in this way, ax squared plus bx plus c. Quadratic function because it's throwing in the f of x. These are all pretty much the same thing. If you're taking the time to write all this down, I think you're doing a little bit much here. But for standard form, I'm going to ask you to write things in standard form a lot. The powers are in decreasing order. So squared, then to the 1, and then there's no x in this term, just the constant. The last thing you need to know is binomial. Binomial has this prefix bi, which should mean, you should know this, 2, bicycle, bilingual, all those things. So as an expression with two terms, here's an example, x plus y. Quiz yourself. Write this in standard form. I just told you, standard form was to have them in decreasing order. So I'm going to distribute this negative sign, which is the equivalent of distributing a negative 1. I'm going to go right down here and do this. You can't read that. 3x minus 5. Now it's plus 2x squared. I've noticed a lot of you are forgetting to distribute the negative over. How can I write this in standard form? I'm going to put the 2x squared first because that's the highest degree. The plus 3x and the minus 5. You just have to be careful with your signs here. That minus goes with that 5. Okay, thanks for the color commentary. The expression 2w squared plus 168w plus 1728. This is in standard form because the squared, then the first term, then no w. So if they want to know what a, b, c, and x equivalents are, what is a going to be? 2, because that's what's in front of the x squared. B would be 168. C would be 1728. And the equivalent to x in this example is w. This labeling of the a, b, and c is important for when you guys do the quadratic formula. I hope you guys remember that from algebra, that Happy's little song. X equals negative b plus or minus square root b squared minus 4c all over 2a. I hope you remember that because we will be singing it this year. This is completely review. Binomial square theorem, and I am confident while I say it's completely review that you did not have this memorized. X plus y quantity squared equals this guy. Where is this coming from? Well, it's x plus y times x plus y. Okay, how do you solve something that looks like this? Do you remember double distributing, or you may have been taught to call it FOIL? FOIL is kind of a lame thing to call it because it only works with binomials, but it was first, outer, inner, last. I like to think of it as double distributing. You distribute the x first, and I get x squared plus xy. I distribute the y second, and I get xy again, and y squared. Combine like terms, and those middle terms will always be like terms. So I have x squared plus 2xy plus y squared, which is just what it says. So you can memorize it. How do you memorize it? You square the first term. You multiply these two together and then double it, and you square the last term. I would say that I have only had a couple kids memorize this theorem. Usually it's easier to go ahead and double distribute it out because you're not going to do enough problems where you memorize it. Back whenever I used to take algebra, I would have to do 20 problems that looked like this, so I would see the shortcut and would be able to memorize it. But you guys don't have that many, so I think it'll be easier for you just to go ahead and expand it out. Just like this one, x minus y times x minus y, x squared minus xy. When I distribute the negative y here, I get minus xy again. And negative y times negative y is plus y squared. Combine like terms, and you get this. X squared minus 2xy plus y squared. Okay, so while you could memorize it, I really don't think it's necessary. So let's expand this. Double distribute. Tell me you remember this. Do you remember this? Yeah. Yes. Okay. 3n times 2n is 6n squared. 3n times negative 5 is negative 15n. Distribute the 1 now. 1 plus 2n is 2n. I said plus, but you knew I meant multiply. 1 times negative 5 is negative 5. Clean it up if you can. That's 6n squared minus 13n minus 5. And that's your, when you expand it, that's your answer, yeah. This guy, x plus 5 quantity squared. I could do the formula. If I did the formula, it's the first term squared. That's x squared. Multiply those two together. That's 5x. And double it. That's 10x. Take the last guy squared, that's plus 25. You can do that. Or you can just expand it out, and I know it's kind of hard to see. Double distribute, x squared plus 5x. Distribute the 5 now, plus 5x plus 25. There's where that doubling comes in, x squared plus 10x plus 25. Okay, here's another binomial squared, so you could do the shortcut, square the first term, a squared, multiply those together, and I get negative ab, double, negative 2ab, square the last term, it's plus b squared, or you could expand it like I just showed you, but I'm not going to do it again because it seems like a waste of time. I know. They do look the same. 2's and a's look the same. Okay, these are the ones that are going to cause you problems. I'm almost confident there will be one on the quiz, so please pay attention to this. Xavier wants to frame an 8 by 10 photograph. The framing material is x inches wide. Okay, I'm going to strongly encourage you to draw a picture. So I have a photo. It's Dustin. I know it because his name is under it. Okay? Okay? It's an 8-inch by 10-inch, so this is 8 inches and this is 10 inches. It is framed. How big is the frame? I don't know. All it says is that the frame is x inches wide. So this is where you're going to mess this up. This is x inches. Guess what else is x? This is x inches. This is x inches, and that is x inches. People want to forget that both sides are coming into play here, okay? So when I want the total area of the frame, this outside area, which area of a rectangle, we should know this, base times height, right? How long is this top? Well, I got 8 here. And what do I have here? X and x. So 8 plus 2x. Do you see it? Okay, going up and down, I have 10 here, x and x. So that is 10 plus 2x. So what is the expression for the total area? Well, I'm going to take 8 plus 2x, that yellow kind of shows up, okay, times 10 plus 2x, double distribute, 8 times 10 is 80, 8 times 2x is plus 16x, distribute the 2x now, 2x times 10 is plus 20x. 2x times 2x is 4x squared. Combine like terms. I'm going to put it in standard form here. 4x squared plus what? 36x, I think, plus 80. That's what they're wanting, the expression for the area of everything. So then if I told you it was a 4-inch frame, you could go and plug in 4 for the x, and then you could tell me the total area of that. Okay? To find an expression for the area of the frame, not the photo, I call this a donut problem because I don't want Dustin's picture in there. It was just that little paper picture of the stranger. We usually throw those away. So I have the whole area is 4x squared plus 36x plus 80. I am going to take out the picture. Well, what was the picture? It was just an 8 by 10, which is 80. So once I add 80 and subtract 80, I cancel out. The expression for the area of the frame, not including the photo, 4x squared plus 36x. So again, if I said it's a 5-inch frame, you could plug that in and tell me just the frame, not including the photo. You will see those again, so make sure you pay attention. Okay, last example. I hate how you can't read it very well. Can I move it up? I want to move you. There it goes. Okay. A city parks department wants to build a brick walkway around a rectangular flower garden. Okay, so draw a picture. Does it say rectangular flower garden? There's some flowers. Kind of looks like a boom box. I better put another one in. That's kind of better. Oh, that's pretty. Okay. The garden is 6 feet wide by 25 feet long, so that's 25 feet. This is 6 feet. And what are we putting around it? Some like brick walkway. All the way around it. Doesn't really say. I'm going to assume, though, that they're not getting fancy with any curve action. So we got some sidewalk here. Okay, find an expression for the area of the walkway if it is x feet wide. This is just like what we were talking about. X, and x. So now we are going to do 25 plus 2x. And 6 plus 2x. The expression would be those multiplied together. I'm going to... Am I writing this right? 6 plus 2x. Okay. 25 times 6, that's 6 quarters. That's $1.50, right? Oh my gosh. I hate when that happens. Oh my gosh. Why does it do that? I hate when it does that. You guys think that... Okay. I hate when that happens. It's so embarrassing. Okay. Do you think that hot pink showed up okay, didn't it? 25 times 6. What's 6 quarters? That's $1.50, I said, right? $1.50. Plus 50x plus 12x. That's 62x. 12 times 2 is 24x squared. Did I mess that up? Okay. I think that's right. So this is the area. If each brick covers 1/4 of a square foot, how many more bricks are needed to make a 5-foot wide walkway than to make a 4-foot wide walkway? Okay, so I have to think about this one. Each brick covers 1/4 a square foot. That's not necessary yet. How many more bricks are needed to make a 5-foot wide walkway than to make a 4-foot wide walkway? So this is the area. So let's figure out what the area will be. The area of a, what's first? 5-foot? 5-foot walkway. I'm going to plug in now 5 for x. So I need my calculator, which I put somewhere because I thought I might need it. Oh, great. Okay. So I'm going to plug in 5. And I get 150 plus 62 times 5 plus 24 times 25, because that's 5 squared. I got 1,060. It'd be cool if somebody else was doing this to check it. This is not 24x squared? 4x squared. Thank you. See, this is why live studio audiences are good. So now my area is wrong, right? Okay. Because 2 times 2 is 4. Why did I put 24? Oh, I thought it was a 12 because I was sloppy. I had a case of the Dustin Walker paper. Okay, plug in 5. 150 plus 62 times 5, right? Plus 4 times 25. Does that sound better? 560. 560 square feet. The area of the 4-foot walkway is going to be 150 plus 62 times 4 plus 4 times 16. And I get 462 square feet. We want to know how many extra bricks I need, so I kind of need to know the difference of the area here. So I'm going to take 560 minus 462, and I have 98 square feet difference. That's not what they're asking me, though. They're asking me how many bricks, and each brick covers 1/4 a square foot, right? So how many bricks will I need for 1 square foot? 4 bricks. So I need this 98 square feet. I'm going to take that times 4 to figure out the number of bricks, and it looks like 392 extra bricks. The reason a question like this would be important, it's kind of like that group test we took on the statue problem. If you have a set budget for bricks and you're like, well, maybe we can make it a little wider, it might look nicer, you need to see if you can afford it, and this is taking materials into account. All right? So that's it for the examples. Here's the homework assignment. I would like you at least to start it, and then we will look at it next time I see you. All right.
Bye.
Goodbye.